Hello everyone, and welcome to this edition of Inside the Naval Postgraduate School. From our beautiful Rose Garden here on the campus of NPS in Monterey, California, I'm your host Alan Richmond, right here on the Pentagon Channel. Welcome to the show. Well, we're jam-packed in this episode. We'll take you to GIFIX, we'll take you to dirt ops, we'll take you to the construction of a SIP hut, and much more. But first of all, let's find out what happens at GIFIX, the Joint Interagency Field Exploration event recently held at McMillan Airfield at Camp Roberts, California. Let's check in with our buddy Ray Bittner. Well, on the road again with Dr. Ray Bittner from the Naval Postgraduate School, and we find ourselves at GIFIX at Camp Roberts, and the magic question is, what does GIFIX mean?
So GIFIX is Joint Interagency Field Experimentation, Alan, and what we do out here for our OSD sponsor is we work with the combatant commanders, the Northern Command, Pacific Command, Central Command are all out here now with a few of the other commands, including Strategic Command and Transportation Command. And we are exploring the edge of civilian military capabilities that can enhance the effectiveness of the warfighter. Along the way there, we're working with our partners and co-sponsor from the Department of Homeland Security to explore humanitarian assistance disaster relief capabilities and technologies. And we find actually a lot of overlap since the U.S. military is one of the primary supporters of humanitarian assistance efforts around the planet.
What makes this GIFIX different than, say, the last one? Is it that what you learn at the last one you try and expand and improve and make it larger or more people, or is it different technology?
So we have been growing the GIFIX project, and we are now kind of reaching our perfect mix of capacity with the right numbers of folks and everything. We actually had 95 candidate technologies that were assessed, and we only invited 65 out this time. And the reason for that is if we get too big, we don't get enough collaboration, we don't get that unique mix of collaborative learning that takes place when industry, government, end users all talk and work together. So if we get too big, we start running into issues. So this is the first GIFIX to kind of really hit its size limits and for us to actually have to start constraining participation. Again, the focus is on those problems that the warfighters and our first responders have. The real idea is to inform on the government side the ability to write the requirement to understand the need for what we need to acquire down the road in the acquisition system. And for our industry and academic folks, is to understand the government's problems and challenges, whether they be humanitarian assistance for FEMA or if it's the next generation Puma aircraft to support a warfighter.
So to be clear, Ray, though, this is not a sales convention or a conference. This really is about pushing the limits of the actual equipment to support the warfighter, right?
Absolutely, and you said it exactly right, Alan. This is about pushing the limits of the technology and the equipment, how fast it goes, how far it goes, how it solves the problem of the warfighter. And it's about that capability. It's not about the sales of an individual product. So all of our industry participants and lab participants and academic participants are helping us understand that technological envelope, where the edge is. Because in today's world, that edge is increasingly fast and accelerating through technological change. Things like your television are lighter, cheaper, faster, and way better than they used to be. And the military needs to keep up with that industrial engine here in the United States. And GIFIX is one way that the Office of Secretary of Defense is using to try to make sure that those combatant commanders have an opportunity to stay at that cutting edge of technology.
And collaboration is probably the biggest key word about this event, isn't it?
Yes, I mean, this is a very appropriate event for the Naval Postgraduate School to be sponsoring because it is a learning event. The idea out here is lower the barriers as much as possible to collaboration. So you've heard me say before, we want to be safe, secure, and legal, and that's all the structure we want. We want maximum communication between the folks who have the technological capabilities and the people who have the need for them.
Well, it's a great time to get technology and a lot of people collaborating together. So again, thanks, Ray, for being with us, and it's always good to be in the field with you.
My pleasure, Alan.
Ray, thanks very much for all your hard work here at GIFIX. Well, another one of our NPS faculty members is on hand to talk about unmanned vehicles and swarming. Here is Tim Chung. So we're at Camp Roberts at the GIFIX, which we'll explain in just a moment. We're talking with our friend Tim Chung. Tim, talk a little bit about what GIFIX is about this time around and what you'll be flying, because we have different kinds of aircraft.
Sure. Well, GIFIX is that Joint Interagency Field Experimentation Program. And what's great about it is it really brings a lot of different people, both on the stakeholder side as well as on the experimenter side, and puts them kind of all in a nice little melting pot for them to percolate new ideas potentially and facilitate communication. So Arsenal, my group, which is the Advanced Robotic Systems Engineering Laboratory, has a number of research projects, and what we'll be demonstrating here and working on is to look at effectively moving towards swarm UAVs. Effectively, the idea is to be able to deploy large numbers, not just 2 or 3, but we're envisioning a day where we can fly 50 UAVs at a time. And the challenges, both on the technological as well as on the human factor side, are quite remarkable, very interesting these days. So we're working with a lot of commercial off-the-shelf type UAVs, as well as RC turned into UAV, RC turned into autonomized UAVs as well that we'll be test flying this week.
And all of this, of course, is in support of the warfighter.
Absolutely. I think the main idea here is tying the research and development efforts that we can do at NPS and other research institutions and being able to relate it back to the operational warfighter context. I think that's one of the key unique aspects of the Naval Postgraduate School.
And the last time we were here, I think we had 10 swarm, right?
That's right. Back at our previous experiment, we were able to fly 10 UAVs simultaneously. We had 2 operators on the ground, which meant that they were each individually responsible for about 5 at a time. And so from the lessons learned there, we're back to do additional types of testing and pushing the boundaries yet again.
And when you say push the boundaries, I mean, that really is true, that you really need to push the envelope to find out how far the technology can go. And so if something fails, this is the place you want it to fail.
Absolutely. We often say, I typically walk into the lab and look at my students or my interns and ask, hey, anything break today? And typically the reason why I do that is because if they're not pushing the boundaries like we're talking about, then maybe they're not really trying to push the limits of either the technology or the hardware or the software or their own knowledge about the field.
How does the weather affect it? Because I know if it's too hot, sometimes with the thermals can have an effect on these flying too.
Absolutely. I think that's one of the reasons why we love coming out to Camp Roberts and other field experiment sites, is because there's nothing like the real world to test our mettle. And so things like environmentals, but also things like frequency management, all those things are potential issues that might not occur in the lab, and it's only out here that we really get to test how good our work has been.
So the magic question is, when do we get to 50?
Great question. We're all waiting anxiously. So we envision our roadmap kind of lays out over the next year to progressively get to the point where we incrementally develop all of the requisite technologies to get to a point where we can fly 50 in about a year.
Well, stay with us. There's lots more on Inside NPS coming up right after the break here on the Pentagon Channel. Welcome back to the show. Well, you're probably wondering, what is a SIP hut? Well, we're here to tell you. Actually, Colonel Fred Meyer is here to tell you. Colonel Fred Meyer is the Deputy Department Head of the Department of Civil and Mechanical Engineering at the United States Military Academy at West Point. Fred has been a commissioned officer in the U.S. Army Corps of Engineers for over 29 years and has been a member of the USMA faculty since 2002. He teaches courses in basic mechanics, structural steel design, reinforced concrete design, structural system design, and construction management, and has also advised numerous cadet independent study projects.
What we have here is called a SIP hut, and SIP stands for Structural Insulated Panel. And so what we've done is we have built a replacement for the standard Army B hut that has been around for decades. But this is a much better option for Army soldiers and military soldiers to live in, because it's well insulated, it's well sealed, and it's going to be much more durable over time than a standard Army B hut would be. Well, we started this morning about 9:20, and we have 2 officers and we have 4 enlisted soldiers helping us here. So it's about 4 o'clock in the afternoon now, and we've made good progress today. Overall, we think it will take about 6 squad hours, where a standard squad would be about 8 soldiers. So we think about somewhere between 60 and 70 person hours overall to put this building together. So the purpose for this really is several-fold. Number one, there's a big time savings in assembling this building. If you look at a standard B hut, the time to build it is much longer than this structure here would be, but the energy savings is really the most dramatic benefit of this structure here. You have much increased R values in the roof, walls, and floor. You have about an R40 rating in the roof, R26 in the walls. and an R30 in the floor. So this is like living in a thermos bottle. It's very well insulated and it doesn't leak. You don't have a lot of infiltration from the outside. So what that means is it takes far less energy to keep this building cool or warm in comparison to a standard B hut or even a tent or any other living structure that we're currently using. So in this building, one of the things you have to be cautious about is the fact that since it does not leak, it does not have a lot of air infiltrating into it, you have to exchange the air that's inside the building with fresh air from outside. So what we have is what's called an HRV, a heat recovery ventilator, and essentially what that device does, it brings in outside air, it replaces the inside stale air with the outside air, and to prevent the energy loss, the cool from the inside or the heat from the inside, it runs that air across a heat exchanger. And those are usually about 80% effective in transferring the heat or the cool to the incoming air. You can put soldiers in this, you could put a TOC in this, you could put an aid station in this, you could put anything that you want into this structure. These panels can be configured to any configuration you want. It can be tailored for any use. We could expand the size of it, we could reduce the size of it. Really, the sky is the limit on this structure here.
Well, that's what I call fast construction. Special thanks to Colonel Meyer and all of his associates who put the SIP hut together. Well, from the ground, we take up to the sky with Adam McDonald and Puma. Well, we're at GIFX at Camp Roberts, and as we've been talking with different vendors, we have happened upon Adam McDonald. And Adam, your company is here testing equipment, a UAV. Tell us a little bit about the company and what you're doing.
Sure. AeroVironment makes a large variety of unmanned aerial vehicle systems, one of which we're showing today is the Puma. It's a small hand-launched 13-pound class aircraft which we've integrated a specialized payload on. And this particular payload is a synthetic aperture radar. That's very important for applications where, unlike EO, you might not have the ability to see through clouds and dense fog and haze. Radar can penetrate that and get through to see things that electro-optic systems like IR and visual systems just can't see.
Well, this morning we had kind of a unique launch of the Puma from a blue truck. Tell us about that. Why did that work out today?
Right. Well, most of our launches are done by hand launched. They're very light and small aircraft, and that's the way our warfighters typically prefer to use them. In situations where we're developing a new payload, it's typically a one-off, fairly expensive payload in the prototype stage, so as a risk reduction step, we like to use a mobile launch where we can get wind under the wings. We're assured that we get a good, stable, clean launch without the opportunity to put that in the dirt prematurely. So it's a fun way to launch, and but maybe not as typical as our warfighters would typically expect.
And it was flawless this morning.
It went off well. I was pretty happy.
How is the testing going? Are you achieving the results that you anticipated, or are you learning as you're going?
We are. No, we're learning a lot of information. We're collecting data for this. One of the concerns is a small platform isn't necessarily as stable as a large platform, and we're understanding that we are able to achieve the results we're hoping for with a small platform. And that's been very promising.
Now, a lot of the GIFX and the TNTs and these different events are all about testing and pushing the equipment to the limits, but the biggest part of it is about collaboration. Do you find that you're learning new things from other companies and sharing information that's kind of helping you at the same time?
Yeah, this is a unique venture. There's a large number of folks here that we'd love to partner with in terms of trying to come up with using their technologies to integrate with our platforms, and through that symbiosis really come up with a much better product. 1 + 1 = 3.
And so the testing that you're doing now, a lot of this technology is being used in theater by the warfighter, and the bottom line really is to develop new technologies to help support the warfighter.
That's one of the unique things about the Puma. It's been deployed in large numbers in theater, and it's a very familiar system. It's a full program of record, and the operator is very familiar with it. So when we do put a unique platform payload on there, they're already familiar with the aircraft. It's just a matter of using the payload for what their intents and purposes are.
Now, you mentioned the weight. How long can this craft stay aloft, and what can you tell us a little bit more about the technical side of it?
Sure. Well, let's talk about the payload, because I think that's the most important thing. It's got very good duration, and we're still testing exactly what that duration is going to be, so I don't have good numbers for you at that point yet. But what a synthetic aperture radar does is it synthetically builds a large aperture. So in radar systems, if you're a radar designer, you'd love to have the biggest antenna that you could afford. Problem is, in a small aircraft, you don't have that luxury. So you can use a technique called synthetic aperture to build a large antenna by using the motion of the aircraft as it courses through the airspace. And after a certain amount of time, you're able to stitch together a picture with radar that looks awful lot like imagery that you might see through a camera. So warfighters, first responders looking through dense forest fire smoke, marine applications where you're trying to look through sea fog and dense fog on the ground. Now you can penetrate that and see all your targets below it without sacrificing optical clarity.
Well, thanks for joining us and being part of the GIFX exercise here at Camp Roberts, and good luck with your testing the rest of the time you're here.
I appreciate it. Thanks for the opportunity.
The Puma, quite an interesting UAV. Thanks, Adam. Well, coming up next, we have much more on Inside NPS here on the Pentagon Channel. You know, from Inside NPS, we take a short look inside the nation's premier national security research university, but there's so much more to the Naval Postgraduate School. Everything from the latest current news to detailed information on all the NPS academic and research programs is just a click away. Visit us at www.nps.edu and get to know all of NPS. We'll be right back. Welcome back to the show. Well, as you know, when you're in the middle of nowhere and need to land a plane, or if you need a road to support the warfighter, you have to have construction, fast construction. Well, that's what Dirt Ops is all about. To tell us more, here's Jeffrey Waugh. Well, another one of the companies that we're talking to here at GIFX at Camp Roberts, California is Operation Ready Dirt, and with me is Jeffrey Waugh. Jeffrey, thanks for taking time to talk to us.
You bet. Thanks for having me.
Operation Ready Dirt. Now, that conjures up a lot of different things, but this is something that actually is another tool to help support the warfighter in the field. Tell us a little bit about the company and what you're doing here at GIFX.
Sure, absolutely. We developed the technology about 4 years ago, and it's a road building technology, and it's a water-based polymer chemical solution that we actually integrate into the inherent in situ soil that you find in any forward operating area or even here in the United States. It can be installed using many different forms of machinery. It's very scalable from a farm implement with a tiller attachment to it to integrate the product all the way up to a multi-million-dollar reclaimer.
Well, we have a sample of the product right here, and it's kind of interesting. Why don't you tell us about it, Jeff? How does it work, and what did you do here as part of the exercise with this?
Absolutely. This is a sample of simply dirt aggregate that you would find just like we have here on site. We integrated the product in at a ratio of approximately 4 parts water to 1 part of our product, our polymer solution. This is actually a core sample that we use in the laboratory setting to find strength gains that we'll find in the field where we're going to be applying the product. We find gains upwards of 600% and above. PSI ranges anywhere from 300 to 600 PSI, or excuse me, 300 to 6,000 PSI. Today we actually put down a road. It took us about 3 hours, 1,000 feet long by 20 feet wide. It's a substantial road. It'll hold very heavy machinery here. The road that we've put down today can hold the heavy military vehicles with no problem. Weather's not an issue. It is water resistant. And the only pieces of equipment that we had to use today were a grader, a water truck, and a compactor. And we took the soil that was already in place, we integrated it using the blader attachment on a roto grader, sprayed the product, compacted it, and then we added a topical seal coat. And that road should last years to come. We have roads that have been in place for over 3.5 years with no need for maintenance, with extremely heavy vehicular traffic. One of the most important things to us, as it pertains to the military, is how quickly we can do this. With the right equipment, if we were to have double the amount of equipment we had today, we could have probably gone through and done 2 kilometers of road, 2 miles of road work just today alone, and it would have been drivable tomorrow.
Well, as we all know, communication is key, especially communication in the field. And wireless communication research is new technology and expanding all the time. With more on that, here's Steve Kroper.
Parallel Wireless is a developer of the software and hardware that lets one have very, very low-cost, flexible nodes that have LTE. LTE is the current signal we all use for telephone calls. So we make very, very inexpensive, very flexible nodes that provide cell phone service, to put it simply, in any area.
Talk a little bit about what you're doing here at GIFX at Camp Robert.
So yesterday we set up at GIFX so we could provide a demonstration of how we very quickly set up an LTE network, either in a small village or, if you imagine, in an area which has lost cell phone service, but the embassy and other U.S. government buildings need service. And we came here originally intending just to light up this area. And if you can imagine, the way our service works is you give let's say 5 nodes, 5 briefcase-sized boxes. Set one of them up on the hill over there, one on the hill behind us, one in the imaginary church, and one in the building behind us. These nodes start talking to each other, and without human intervention, they set up basically a cell phone network and a Wi-Fi network in the area. So that's what we came for.
Steve, talk a little bit about the actual device that we're looking at.
So before our development, if you wanted to wire up a city, or if you wanted to wire up a hamlet, you would need a pallet, 4 foot by 4 foot pallet, 4 feet high, approximate cost $50,000. The nodes that we've developed, the manufacturing cost is $1,000, so you can imagine that the end price is relatively low. And it's also the size of a milk crate. So milk crate versus pallet, let's say $2,000 versus $50,000. And one of the reasons why the low price matters is, supposing you put it up on that hillside and it gets captured, it gets destroyed, it gets run over, nobody gets demoted, nobody gets fired, because we think of these as being disposable now. So the price makes them disposable, the size makes them portable.
And so this is really a part of disaster recovery is the focus.
Think of it as one of 2 possibilities where the civilian cellular system has been disabled and U.S. government interests want to set up an alternative, or where it's been lost, as you said, earthquake or other disaster.
Okay, now you can also do video conferencing with this system, correct?
The demonstration that we did yesterday showed that we could use FaceTime or Skype, 2 common video tools, and fairly high bandwidth applications, to communicate within the village, and then also because up on the hill we have a mobile satellite truck which we're using for egress, in other words to get outside the area. We were able to demonstrate video between here and Maryland in a network that took 45 minutes to set up end to end, and more importantly was between 4 different vendors. So while we were parked here, we started talking to our neighbors at GIFX. 1 fixed satellite operation, 1 mobile satellite operation, 1 TV white space for backhaul, and then us parallel wireless. We started talking, we're trying to think, how can we put together a demonstration that's more than just building a cell network here? About 45 minutes later, the satellite guys drove up on the hill, they provided us with egress, we provide the local network. So 45 minutes, we get an end-to-end network providing cellular, broadband voice and data out to the real world.
So it really points out and substantiates what GIFX is about, and that's collaboration.
We hadn't previously done any egress to satellite. We knew that we could connect, no previous experience with satellite. Likewise, we hadn't used white space for these kind of local connections, and we never even heard of the idea that you could put satellite on a vehicle moving 70 miles an hour to avoid being a target. So before yesterday, we just had great local networking, and now we've gotten experience getting it out to the real world.
Well, I'm sure you'll agree business and technology go hand in hand. And here at GIFX, it's a great opportunity to showcase your work and what your company can do to support national security and the warfighter. Here's an example from Gabriel Rea. Gabriel, tell us a little bit about CS Solutions.
CS Solutions is a software development company that develops cybersecurity software for computing platforms for both Department of Defense, federal and civilian and commercial segments.
The software that your company produces actually really has a big hand in support of the warfighter, which so many of these things that go on at GIFX do. Explain how that supports the warfighter.
Sure. Our software sits on the computing platform for the warfighter, and it allows 2 major benefits. First off, it keeps that warfighter system in an IA compliance, which is necessary to operate on classified systems. Secondly, if attacked by a virus, the warfighter all would have to do is to reboot the system. Even if there's no operating system, the warfighter just hits 1 button, reboots the system, he's back up operational. So we maintain operational continuity for that warfighter without him calling back to the help desk or trying to get support in the field.
Your company, CS Solutions, is really an interesting story about how people come to GIFX and collaborate, but a lot changed for you after being here for a couple of years. Tell us about that.
Sure. When we first came on board, we just started the experiments and collaboration. GIFX supports a JVAB, which is a Joint Vulnerability Assessment Branch, to do assessments on software, security software like our software. And through the years of progression, we have been increasing the security elements of our software based on those assessments. And we've also been highlighted. DHS has asked us to be part of the Safety Act. We submitted, and we have been able to be qualified as an anti-terrorism technology company. And so with the collaboration with the other technology providers, we've been able to integrate our solution set and to make a stronger set of communications, both communications and technologies for the warfighter and first responders.
Well, that's terrific. Congratulations.
Thank you.
What do you think of GIFX? Obviously, I would guess that you're pretty pro this kind of event, but you collaborate and find out about new technologies at the same time you're presenting yours, right?
That is correct. It provides an open environment to learn what other companies, even in their infancy stages of understanding where their technologies are, to help them develop their technologies to meet the requirements for the federal and Department of Defense companies. And so what we're able to do is that this forum allows for test evaluation, an open forum where you're not going to get penalized for your software not working or whatever the case may be, then to allow open collaboration so that we can actually build a solution set to support the warfighter or Department of Defense.
Well, that's great. Well, congratulations, and
Thank you.
appreciate you being on the show and explaining all that to us.
Thank you very much.
All right,
It's a pleasure
dear
being
Pro.
here.
Well, that's it for this edition of Inside the Naval Postgraduate School. From our campus in Monterey, California, I'm your host, Alan Richmond, right here on the Pentagon Channel. Thanks for joining us. Take care, and we'll see you next time.